Hello students, we're here with the angle bisectors and the angle addition postulate, day 2. Alright, so we just read the iBook notes, we got a good understanding on what's going on. Furthermore, this stuff's a lot like segments. We've had segment bisectors or the midpoints and segment addition postulate. So it's really just extending what we were doing on segments into angles. Alright, so understanding what angles are, how they work, and how to make them are important. They help us build better streets and cities. Angles help us tell times using the sun and shadows, and they make it possible to measure how far away the planets and stars are. All right, so angles is a very powerful concept. Hopefully you can realize that, and that's why we're talking about them in the first unit of geometry. We're in the second part of the first unit. So just to warm up, we're going to identify 3 unique angles in the pictures below. And why do we need to use 3 letters? I can't call this angle A. All right, if I say angle A, am I talking about this angle? Well, that has a vertex of A. Am I talking about that angle? Well, that's a vertex of angle A. Am I talking about, I don't know what I'm talking about. Angle A is not specific enough. In this particular case, when there's multiple angles, I have to use 3 letters. So I can say angle D, A, J, and then furthermore, I could see J, A, D. All right, what's important when I name an angle is that the vertex is middle. It's the middle point. All right, it tells a story. You start at D, go through A, then go through J. All right, or I go through J, end up at A, go through D. All right, it tells a story, a specific order. All right, it doesn't matter the order, but A has to be in the middle. I could say angle JAT, and you could say angle TAJ as well. And that's this angle right here. So these are the 2 smaller angles. And then lastly, we got the whole stinking thing. We got angle DAT, or you could call it angle TAD. All right. So we have to be good at naming angles using 3 letters. We're going to do it the whole year. All right. I know it can be a little awkward, a little quirky, but the better you can get at it, the quicker you can get good at it, the more success, or the quicker that you're going to have success later down the road. All right. So discuss the difference between congruency and equal. All right. Shapes. We say congruency when shapes are the same. All right, so in this particular case right here, now I can use just 1 letter because there's only 1 angle floating around. I can say angle A is congruent to angle B and use those little arc marks. Those arc marks are like tick marks. They tell us when angles are congruent. When shapes are the same, we say congruent. All right, so that angle is congruent to that angle. All right, equal measures. When an angle has a measure, that's some number. Measures are the same. So hypothetically, I'm just going to make up a number, 57. Technically, I didn't make up the number 57. That already existed. But anyways, you would say the measure of angle A equals the measure of angle B. All right, because they're both 57 degrees. All right. And then I've had a student ask before, what does this mean? This right here reads the measure of angle A. I know in geometry we have a lot of notation, mainly because us math teachers, we don't know how to spell. But that little m means measure of angle A equals the measure of angle B, and because they're both 57 degrees, that's why they're equal. Shapes are the same, numbers are the same, congruency equals. It's very similar concepts, all right? Very tedious, but it's still good, and just the way we do it. It's something we have to know and be comfortable with it. All right. So, and then just to emphasize stuff from yesterday, we're just going to go through a series of problems and just emphasize or strengthen our skills, emphasize some things, so on and so forth. So draw a 30-degree angle. All right. So again, we don't have to be that good at drawing. All right. What's this angle? What's its measure? You might not be able to tell, but now I wrote 30 degrees, so it has to be 30 degrees. It says label it GHI. All right, so I'm going to say that's G, that's H, and that's I. Remember, H, since H is in the middle, H has to be the vertex. All right, now ray HF bisects GHI. Bisect, cut in half. All right, just like a midpoint, we're going to have angle bisector. So, boop, cut it. Actually, you know what? I'm going to use red because I'm cutting it in half. That's the blood of the angle. And that's F. All right, it says it's bisecting it. Did I perfectly draw F, or the ray? Did I perfectly cut it in half? Since I put these arc marks, I did. You have to believe it. Now it says, what is the measure of GHF? So it's saying, what is this angle measure? The whole thing's 30. I cut in half, so it's 15 degrees. Because that's also 15 degrees. All right, so I can say the measure of angle GHF equals 15 degrees. Nice. All right. So just another problem with some basic numbers. Given that WZ bisects angle XYW. So it's a really good habit to get into. This sentence right here, let's label it. It's saying that it bisects the angle, so arc. Because now I'm not even reading the rest of the problem. I can start filling in things. Well, if this part is 64, this other part is 64 degrees. Since it's bisecting, it's cutting it in half, they have equal measures. And then that means the whole thing is 128 degrees. All right? And then that ends up what the question was asking. I can write, well, the measure of angle XWZ is 64 degrees. And remember, that's XWZ. XWZ. All right? That's 64 degrees. The measure of angle XWY is 128 degrees. And that was the whole stinking thing. Alright, so just going through some common sense problems, starting at the very basics. In the next videos, look, we're going to start to incorporate some algebra. Yeah, looks like it's so much fun. Alright, stay tuned.